Okay, welcome back. So this is part 2 of the video. At the end of the last video, we'd created our whole floor structure for the project. Now, what this means, I'll show you underneath. We've got bearer and joist construction for the main floor and also for the deck. We've been meeting our specifications so far. We've got particle board flooring across the top. We've got some decking across the back. Okay? And that's where we're up to. Now, you'll see in my components window that I've got all my individual parts here. Again, what I'm going to do is I'm going to make sure I've got one component for the whole project that we've done so far. So see there, whole floor of project. That's everything here selected, made as a new component. So that what I can do now is I can delete it out. And when I need it back again to put my project together, it's as simple as putting it back in. Okay. Save your project if you haven't already. We're going to get moving. What I want to do right now is to start preparing our first wall. Now the first wall that we're going to prepare here is going to be the back wall. This is the wall that has the door frame in it. Okay. Now our wall is made up of a few main parts. Okay. Firstly, we've got our plates, the top and bottom plate. These pieces are identical. So again, we can make a component and replicate that twice rather than doing the work. We've then got studs. These are the vertical pieces. They run up and down the wall. Okay. Then lastly, we have our noggins. Our noggins go between the studs to give additional strength. Okay. There's 3 main parts of the wall there, and they generally hold everything together. In addition, we've got some double-ended studs on this particular one to give the door some extra strength and the wall some extra strength. And then we've got some special terminology that we use for our wall framing. Okay. Now, I'm going to have some questions at the end of this video for you to answer, and I want you to go and research this. But what do you call the piece that runs horizontal above the door? Okay, it looks like it's a noggin, but it's the width of the door and sits at the top. And then there's also a vertical piece, very short, looks like a stud, and it goes above the door as well. So they're the 2 questions that I'm going to have for you at the end of this video that I want you to go and research. The last thing that you can see on your drawing is some metal strap bracing. So we'll get started. If I was building this project, the first thing that I would do is go and cut my top and bottom plates to length. So that's probably where I'm going to start here. I'm going to, again, use a rectangular prism. I'm going to draw the cross-sectional size of the top and bottom plate. Then I'm going to add some length to it, give it a bit of color, save as a component, and we're done. Now, if we go to our specifications, I'm looking at sheet 2 of 6 here. But if we go to our specifications, the wall framing says plates are 35 by 90, the studs are 35 by 90, and the noggins are 35 by 90. So we're using the exact same timber here for all 3 parts of the wall. The only other specification that's given here is that the maximum center-to-center spacing for our studs is 600 millimeters. Okay? So let's get started. Rectangular prism, okay, it's going to be 90 by 35, okay, and we've now got that in. If you zoom in, see your rectangular prism. Change yourself into your isometric view, pull it, and we give that a length. Now, if you're looking at the wall there, you can see that our top and bottom plates have a 3,420 millimeter length. 3,420, enter. Okay, so I've got one stud in. One plate in. I'm going to highlight this. I'm going to give it some color. Now, just with the colors we're going to be using, let's see if I can get some nicer colors to use. I'm going to use this color here. It's a bit of a dark aqua color. Okay, and the reason I'm using that is because we're going to be using timber that's been treated, and it generally comes in that sort of color. So again, you'll learn more about the treatment and specifications when it comes here, but we're going to be using MGP10 radiata pine for the material, and then there's the treatment that goes over top of it. Okay. So once I've colored it and I've got my project selected, you right click, make component. Now I've got to call this something specific. Remember, we're making the back wall here, not the side wall. The back wall and the front wall are identical. They both have a door in the exact same position, so the side walls are separate. The side walls have longer length. Okay, the side walls have longer length. What that means for us is that we need to make sure that we call our top plate and bottom plate for our back wall something different to our top plate and bottom plate for our side wall. So I'm going to call this plate, back wall, Okay. And adding our specifications here, so it's 90 by 35 millimeter MGP 10 radiata pine. Okay. And create. So you can see that's added into my component list there. Again, if you don't have your component window, it's window, tick components, and this should show up. You can make it whatever size you need. So I'm going to delete that out now. I don't need it for now. What I do need is I need to start making a stud. So again, I need to put in my cross-sectional area, which for me is 35 by 90. And then I need to give it some height. Remember, my studs run vertically. Now, for this project, I can see that the total height of my project, of my walls here, is 2,440, but that includes the thickness of the plates. Now, if each plate is 35 millimeters thick, and there are 2 of them, then that's 70 millimeters. So what I do is I do the 2,440 minus the 70 millimeters for the 2 plates, and that means my studs are 2,370 millimeters tall. Push-pull tool, 2,370 millimeters. There's my first stud in creation. Highlight that. Let's give it some color. Again, I'm going to use that dark aqua green color because that's what the timber we're going to be using is. And let's make that a component. This component is a stud. Now, the stud for the back wall and the stud for the side wall, they are the same length because the wall is the same height. Okay, so we don't need to make any specific one here. Stud, it's 90 by 35 millimeter MGP 10 radiata pine. And might as well put that in there and create. So now I've got my stud in position. And the last parts there are the noggins and those extra wall framing components around the door, so mystery pieces. So let's start building, I suppose. So we'll start with our plate. Let's put our bottom plate in, our bottom plate into position. And we're going to need a stud as well. Now, I know from the drawing that there is a double thick stud at the end here. It looks a bit like that. And I know that there is a stud that needs to go on the end of the wall here. And I know that there is a top plate that needs to go across the top. And that's my basic structure of the wall so far. The next thing we need to do is we need to then measure out the distance of the door. Now the door from the outside to the inside of the stud is 970. So I'm going to draw myself a line from here across here, 970, and put my next stud in, and you see it should snap onto that line that we've put in, and we can now delete that line out. Okay, so that's what we've got so far. And the next thing that we know is that the center to center spacing is 600 millimeters, so we can start putting in from center here, 600 millimeter spacings. Again, this is maximum center to center spacing, so it can be less. So don't be surprised if when you're making your wall that you don't get perfect 600 centers to centers. Okay. Now let's see where that last one ended. See that last one there ended and it's not going to meet up. Okay. We must meet that spacing requirement. So I'm going to work my way backwards from this one, 600 millimeters. And I'm going to delete out these center ones, and we're going to have a small spaced stud in the middle. Okay. Now see how we've got 15 millimeters remaining there. It's not really ideal. So let's go back, let's get all of our lines that we've drawn in, let's delete those out. And let's get there is another way that we can do this. We can measure from this distance here, from the center to the center here, 2,415 millimeters, 2,415 millimeters. And instead of using a maximum spacing of 600s, what if we used some 500 spacings? Okay. And that way one of them will be slightly shorter, but it will still be a decent spacing. The other option is we could do the 2415 divided by 450 spacings, which is also not a problem. Okay, so what we're going to do is in here we're going to go 450 spacings. Now the reason I use 450 is because in standard building construction you use either the 600 or the 400. Okay, sorry, the 600 or the 450. Okay, and now we can start putting our remaining studs in. Now remember, the studs are center to center, so you need to get that center piece and drop it there. Okay, now that extra small section of the back doesn't really matter too much, okay, as long as we meet the minimum requirement, which is the 600 millimeter center to center. Now, the problem with going more than 600 millimeters is, firstly, you won't meet the requirements that the architect has given you, but secondly, you also will change the way the amount of strength that this top plate can actually handle. Now, if you don't do that correctly, if you don't have the right spacings, and you put a heavy roof on, or if you have a second story, and there's not enough strength in this plate because the studs are not positioned correctly, then you run the risk of your house actually collapsing, and that's not ideal either. So you want to make sure you've got that correct. And so now that we've got this back wall section here, we can start putting in those last two mystery components. Now, I'm going to refer to them as the horizontal component and the vertical component because, again, I don't want to give away the answer just now. Okay? So I know that from my drawings, I know that from the base of my project here up to the top inside of my door has a height of 2100. Okay, which means I'm going to have a piece of timber basically running across that line there. I also know that because it is a wall frame component, I know exactly what the dimensions must be. It must be 35 by 90, and it then needs to fill that void running across there. Now that void is 970 wide, minus 2 stud thicknesses, so minus 70, so it's 900 wide. So I should be able to now use my push-pull tool, 900, and that should be meeting up on both sides, which it is, excellent. Now what I can do is I can draw around that. I can give that some color as well, so let's give that nice aqua color, and make component. And again, I'm going to call this mystery X component. Lastly, I know that there is that other stud-like component which is in the center. Okay, now the center is just there. It's going to be at that height, at 235 millimeters. So let's draw ourselves a 235 high. I'm going to make it 35 wide. No, let's draw our sectional sizings correctly, hey? Save me doing some shortcuts. So 35 by 90, 235 high, make component, mystery Z component, okay, and we'll move that into position from the center. To the center. Now what I've got is I've got the start of my wall. The last thing that I need to put in is my noggings, and then I also need to put my steel strapping. Now I know that this, and this are all the same size, so I can use one nogging part for all of those, and then this last bit here, in this smaller spacing, I'm going to have to put an extra nogging in. So again, I know what my nogging sizes are. I know that they are 35 thick by 90 in profile. And then I actually know the distance from one to the other. So if I want to be sure, I can just measure it across, and I know that that is from the inside to the inside is 415. So push-pull, 415. And there's my noggin. Give it some color as well. And let's move that into position. Now with your noggins, what you want to do is you want them to be centered, but when you assemble them, you can't obviously have them in the exact same position because you won't be able to necessarily screw them in. So see here how I'm just stepping them slightly off. Okay. The reason we want our noggins here is so that when it comes to our sheet materials, like our gyprock or our villa board that's going to go onto the wall, we want something to be able to secure those into. So we put our noggins here so that we have something for the villa board connected. The other reason we have our noggins is to stop these studs here from suffering bowing as a result of the weight coming down. So this gives additional strength to the wall, as well as giving us something for our sheet materials to hang on to. Now lastly, I need to put a small customized noggin in there. And again, we know what the component's going to be. It's 35 by 90. Now I can measure. Okay, right here you can see from there to there is 130 spacing. So it's just a matter of drawing that out, 130. Let's give it some color. A component, okay. Custom noggin 1, 90 by 35 millimeter MGP 10 radiata pine. Okay. Dun, 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 dun. Command 7. Let's look at it. I've now got my wall. So I've got studs, I've got plates, I've got noggins, I've got my mystery components around the door that I want you to research. Lastly, we need to put our strapping in. Now, to do that, the best way to do it is to go to a front view, like we have here. Now, I can put strapping from basically anywhere here across this way. What I can't do is I can't put my strapping from here across because obviously then it will interfere with the door. And you can't cut through the strapping. The purpose of the strapping is to help keep the wall frame square and to give it some additional strength. And the best thing you can do is actually not put it right on the corners, but bring it in just a little bit. So let's bring it in 150 millimeters, just so we've got a bit of consistency. And it also needs to be held at a 45 degree. So if we know that that length there is 2440, we can also do 2440 that way, which gives us an end point. Okay. That's going to give us exactly 45 degrees. Again, this is going to mean that our strapping is going through the door. So that's not good either. So as long as it's close to, okay, I believe the specification here is at 45 degree angles. You could make it work by working a little bit closer to the walls here, okay? But you need to put your strapping in. Now you know that your strapping is also 30 millimeters in width. So you can measure out your 30 millimeters and you can then, you've then got your first bit of strapping, okay? You can do the same thing down the bottom here. And then you've got to do your 30 millimeter width. And there we go, we've now got our strapping in. I've now got a wall. Okay, that's exactly what we're aiming for. Now the last thing that we want to do is this strapping here has thickness, so I do need to bring it out by 1 millimeter. Okay. And there we go. Select my whole project, make component, back wall. Okay. That's the end of this video tutorial. I'm going to stop there. You've now got enough tutorial here that you could produce the rest of the wall for this project. Remember, it's just the side wall you need to replicate now. All the dimensions are available for you. If you need any additional help, you're more than welcome to ask. As I said, I'd just like you to research the framing components that work around a door. Thanks very much. Save your work and look forward to seeing what you put together. Thanks.